Okay, so I want to prove that the square root of 2 is irrational. Now, rather than trying to prove that as a decimal it goes on and repeats forever, which would be a little bit too hard for me, because I wouldn't know if the 27th billion places where it starts to repeat, what I'm going to do instead is I'm going to prove it cannot be written as a rational number. It cannot be written in the form a over b. And to do that, I'm going to use a method called proof by contradiction. And so I'm going to contradict my opening statement for my proof. My opening statement is I'm going to let the square root of 2 be rational. I want it to be equal to a over b in simplified form. Now, if you think of any fraction in simplified form, I'll write this up here: 1/3, 2/3, 3/5, 6/7. One thing all these fractions have in common is they have odd numbers in them when they're simplified. And that's going to help me to get a contradiction happening here, because I'm going to say that either A or B must be odd. One of them must be odd if this is in simplified form. So I'm going to start by squaring both sides. I square this, I get 2 is equal to a squared on b squared. And so this tells me straight away that a squared must equal 2b squared. So therefore a squared is even. And if a squared is even, then a is even. You think of every even number squared, you get a square, you get an even number. Take an even number, square it, the answer's even. Take an odd number, square it, the answer's odd. So a is even. If a is even, then from some of our work we did previously, I can let a equal 2n. That's an even number. And I can come back up the top here and say, therefore, the square root of 2 is equal to 2n on b, because I know a must definitely be even. So it's 2n on b. Okay, so from here then, again, I'm going to try now to prove that b must also be even, which then gives me my contradiction back up here, that one of them has to be odd. So again, I'm going to square both sides. I'm going to get that squaring this gives me 2 is equal to 4n squared on b squared. And so I will say, by squaring both sides, bring this back up here, running out of room, I get 2b squared is equal to 4n squared. Dividing both sides by 2, b squared equals 2n squared. So b squared equals 2n squared. From previously, that means that b squared is even. And if b squared is even, b is even. At the very start of my proof, I said if the square root of 2 is a over b in simplified form, a or b must be odd. I found a is even, b is even, so therefore the square root of 2 cannot equal a over b. It must be irrational. Proof by contradiction. Rather cool. You actually don't need to know this proof for the course, but it is a pretty cool and funky way to prove something.